Okay, hopefully you're all set with your notes. You got out the ones you were working on before. We're just going to pick up where we left off. And remember that we've been focusing on different ways to solve quadratic equations. So one of the ways is a quadratic equation can be graphed, and it looks like a U, and that U crosses the x-axis. That's one of the ways to solve. Another way to solve is by using square roots. But the one we've been focusing on is the zero product principle. So we're going to keep working on that today. We're going to use the ZPP again to solve these quadratics. But the thing I want you to notice about this particular question, 4x squared minus 21x equals 18, is that it's not equal to 0. You can't use the zero product principle unless you have the equal to part is always equal to 0. So what we need to do is we need to work towards getting that one side cleared out. We need to clear out that 18. So the first step you're going to show is that you're going to subtract 18 from both sides of the equation and then see what you end up with. So the 18 minus the 18, that's going to give you the 0 that you want for the zero product principle. And on the other side, you have 4x squared. And then you're looking at the 21 and the 18. And notice that the 21 has an x on it, but the 18 doesn't. So you can't subtract those numbers from each other because they're not like terms. So it's really just minus 21x and then minus 18 separately. And then we're going to solve this using, now that we're ready for factoring, because we can use the zero product principle. And so we have our numbers lined up, ready to go, our A number, our B number, and our C number, ready to go for the zero product principle. So let's make our star and get ready to solve our different star factors and see what we can come up with. So remember, we start with 4x, and it's squared, so we've got 2 of them in both of those places. We got negative 21 in the bottom, and then at the top is going to go the multiplication of the A term, which is 4, and the C term, which is negative 18, and that is going to give us negative 72. And we've got to come up with all the ways. If you've got negative 72, how can you come up with 21 from those things? So we got to start going through the options of how to make negative 72. So we've got 1 and 72. Negative 1 and 72, or negative 72 and 1. Those are the 2 of our choices. Or we've got negative 2 and 36, or negative 36 and 2. We have a negative 3. Okay, so 3 goes into 72, so we're looking at that at 24, or negative 24 and 3. And we can stop right there because that combination is what's going to produce a negative 21 for us. So if we change this last one to an addition, negative 24 plus 3. So we're looking at negative 24 and positive 3. All right, so we know that this is going to turn into 2 factors that are equal to 0. So our last thing to check is whether or not these numbers can be reduced from each other, and they can. 4 goes into 24, so 4 would go in 1 time, and then the 24 would become a minus 6. So we're left with 1x, and then a minus 6 is our first factor. On the other side, 4 and 3, nothing reduces 4 and 3, so we're left with 4x minus 3. So we've gone through the same process we were doing yesterday, making sure that we apply the star factoring method to come up with 2 parentheses. And then we're going to take each piece and set them equal to 0. So 1 minus x could possibly be equal to 0, or 4x minus 3. And again here, I want you to to get into the habit of showing your work on what you're going to do to get the x by itself. So we add 6 so that we can balance out the negative 6. We add 6 on both sides. The minus 6 and the plus 6 cancel each other out. We're left with 1x equals 6. So our first solution is that x must have a possible value of 6. On the other side, the first thing we want to clear out is the 3. So we're going to add 3 to both sides. That's going to take the negative 3 and the positive 3 and cancel each other out, leaving us with 4x on one side equals 0 plus 3, which is 3. Now I'm not going to subtract the 4, I'm going to divide the 4. Because 4 is multiplied by x, I need to do the opposite, which is dividing. So the top 4 reduces out the bottom 4, and we're left with x by itself, and x would be equal to the fraction 3/4. I think fraction is better. If you want to write a decimal for that, you can turn that into its equivalent decimal, but I always think fractions are going to be better in the long run. So 3/4. So those are our two options, or both of them could be solutions, but we've got one or the other are our solutions using the zero product principle. If you need a little more time, you can ask the sub to pause the video here. Otherwise, we'll move on. All right, so let's just sort of check our understanding of how we're doing this. This is a quadratic. It has a square, so we're going to use the ZPP. But the first check of the ZPP is, are you actually equal to 0? And we're not. So we need to make this equal to 0 by adding 49 to both sides. That will give me 0 that I need. And then I'll be left with x squared plus 14x plus 49. And then we'll look to identify, because this is a quadratic, we want to know what is our a, b, and c. So we've got a, b, and c. But you got to be aware that the a is 1. Okay, that has to be a number. It can't just be the letter x. It has to be a number there. Okay, then we're ready to check our star factor. So 1x and 1x. Positive 14 goes on the bottom. Remember, the b term always goes on the bottom. And then we look at the combination of a and c. So 1 times 49 is 49. Now, there's not very many ways to make 49. It would either be 1 and 49 or 49 and 1, or it's 7 and 7. Those are the only ways. And so 7 and 7 is what we're going to choose to make this work. When we look at the 1 compared to the 7, that's not reducible. So 1x plus 7 is the first factor, and 1x plus 7 is also the second factor. So the zero product principle would help us get that started. If 1x plus 7 equals 0, then when I subtract 7 from both sides, and the 7 is going to cancel out with a negative 7, I'll get 1x equals negative 7. So my first solution is negative 7. On the other side, we're going to have the exact same thing. We'll have 1x plus 7 equals 0 again. So we're going to end up with a second answer. This is called a double solution, where it happens twice, and you get bonus points for recognizing that negative 7 is a double solution. So you could write, that would be super impressive if you would write that down, not just writing one of the negative 7s, but writing that you have both. Okay, I'm going to have you add another question here. This is 3b. And we're gonna look to find the solutions of additional question. And so the question I'm gonna add to this slide, find the solutions of, and I'd like to do x squared equals 8x. Here we have the zero product principle again. So we're going to subtract 8x from both sides. So we're going to minus an 8x from each of the sides because we still need to make sure that this comes out to be equal to 0. Now x squared minus 8x are again not like terms. But it also is not a problem that can be solved with star factor, because in order to do star factor, you need an A and a B and a C. We don't have an A and a B and a C. We only have an A and a B. We only have, this is the A term, that's the B term, but the C term is missing. So we cannot do the typical star factoring. So you're going to do a different kind of factoring. So I'll remind you of that. It's called greatest common factoring. Greatest common factoring is when you look at those two terms and say something about them is the same. They each have an x value. Remember that x squared really means x times a second x. That's what x squared means. So both of them have an x the same, but they have, what's different is one of them has an 8. So we call that GCF factoring, or greatest common factoring. So you're going to take an x to the outside, and then you're going to say, all right, I'm going to take the x's away. So I'm going to take this x away, and I'm going to take an x away from the other part, and what I'm left with is x minus 8. This is called a different kind of factoring. This is called greatest common factoring. It's not star factor method. It's a different kind of factoring. But we can still use the zero product principle since these are equal to 0. And we take each piece and make it equal to 0. So I'll take this front piece, which is x, make it equal to 0. So then my work will be that x equals 0, or I'll take the second piece and it should be equal to 0 as well. So x minus 8 would be equal to 0. Now the first one's already done because x is by itself. Once x is alone, you know you have a solution. For the other one, I need to add 8 to both sides, canceling out the negative 8, and that would leave me with x equals 8, and that would be the second solution. So our zero product principle tells us we get 0 or 8 as the solutions to this problem. All right, last one for the week. Okay, so we're going to do what is called a word problem, and this is an area problem. So I want you to remember that these shapes are rectangles. And so the area of everything that has a rectangle is length times width. Try not to use, I noticed on your homework some of you were doing LX, L like that, you were writing it with an X symbol, but that looks like the letter X. So instead of using X for multiplication, make sure you're using the dot, length times width. Okay? All right, so we want to establish what is the length of this picture, including the wooden frame that's going around the outside. So according to the drawing, 17 is the length of the picture on the inside, but we want to include the wood on either side. So we've got an edge of wood on this side, on the right, and then we also have the wooden edge on the left. And according to the picture, those are labeled both as X. So the length going all the way across is X on the left, plus 17 in the middle, plus another X on the right. So X plus 17 plus X all the way across from side to side. So that's 2x plus 17 if we've combined like terms. All right, now the width measures top to bottom. So the very top is the wooden piece, and that is x. The middle section is 11. That covers all of the picture part. And then the bottom is another x. So if we look at the width, we have x on the top plus 11 in the middle plus x on the bottom. And so that would be 2x plus 11. So my area has to be the length times the width. And so that would be 2x plus 17, and then multiplied by 2x plus 11. That is the length times the width. All right, so now we want to tackle what we would do to this question. So on the A, which stands for area, we're going to put in the number 315 because it says the total area of the frame and the photo is 315. So we're going to put that in for A. On the other side, you're going to do your FOIL. Okay, FOIL is when you multiply out two parentheses next to each other. First, outside, inside, last. So we're going to do first. That's 2x times 2x itself. That's 4x squared. Then outside, that's the 2x at the beginning times the 11 at the end. So that would give me 22. Then we work on inside. That's the two pieces that are next to each other on the inside. That's the 17. So I know you learned this with Miss Graham. That's 34x. And then we want last. And you'll for sure want your calculator to be able to do that, okay, because you're going to be doing the last number of 17 and the last number of 11. So even I need my calculator to multiply what 17 times 11 is, and that's 187. Okay, great. Now we're ready to solve this, and we have to use the same ZPP principle we've been using the whole time. The ZPP says this has to be equal to 0. And so the number that we're going to want to subtract to make this be equal to 0 is the 315. That has to get subtracted, and it gets subtracted from the 187 at the end. That's the only way I'm going to make this problem equal to 0. We'll have 4x squared. The middle two terms, 22 and 34, add up together. They make 56. And then I want 187 minus the 315, and that would give me negative 128. Now I know that problem might look intimidating to you, but as long as you have a calculator, you can always figure out, even though the numbers are big, you should be able to figure out what numbers are going to make this work, because we have an A number and a B and a C. And so we should be able to do the star factor method. Okay, it'll always work, no matter how big those numbers are. So we have 4x, and then another 4x, and then the bottom number has to be 56. And then we're going to take our front number of A and our back number of C, and we're going to multiply those together. That's going to give me negative 512. Now again, that might be intimidating to see, oh man, how am I going to figure out what numbers go into 512 and do like my, adding and subtracting and stuff. So it's totally okay. You just gotta start experimenting with numbers to see what's going to go in there. So Is it going to be 1 and 512? Okay, well, that's not going to make 56. Is it going to be 2? And well, then you've got to figure out what would go in with that. Is it going to be 2 and 256? Or excuse me, negative 2 and 256. Is that going to make? Nope, that doesn't make 56 either. Okay, well, how about 3? Does 512 go in by 3? And it doesn't. Okay, 3 doesn't go into 512 nicely. How about 4? Would 4 work? Negative 4 and 120. Okay, that's not it either for 56. How about 5? Nope, 5 doesn't go into 512 because 512 doesn't end in a 0 or a 5. You're keeping on practicing with numbers until you find things that go in perfectly all the way. Okay, the next number that goes in is negative 8 and 64. And that's the combination that works. That's the combination that when you turn it into an adding, negative 8 and positive 64 work out. Okay, so then we just need to finish up by reducing. And when we compare the 4 and the negative 8, those two reduce each other. Okay, because they're both, 4 goes into 8 perfectly. So I can reduce the 4 to 1 and the 8 reduces to 2. So my very first factor is 1x minus 2. That's perfectly reduced. On the other side, 4x also goes into 64, and that can be reduced. The 4 by it to 1, and the 64 is to 16. And so we have, okay, that'll be 1x minus 16. And then that gets set equal to 0 for the 0 product property. Now we'll take each piece. 1x minus 2, we set it equal to 0, or 1x minus 16 gets set equal to 0. We'll go back to the first one and add 2. So it turns out that x equals 2. And then the other one would be or. We add 16 to both sides. And then x would equal 16. Now remember, in this word problem, it's one or the other. Okay, and one of these answers makes sense, and one of them doesn't make sense. Okay, looking, now x stands for the edge of the frame all the way around. X is not very big. Compared to the whole frame, that's 17 inches of the picture and 11 inches by the picture, it doesn't really make sense to use 16 as an answer. It's way too big for this picture frame. And so you always got to go with what the answer that makes sense is. And so the answer that makes sense is this one, is x equals 2. It's not going to, remember, it's one or the other. So the 16 is not our answer. So our answer is 2, and then you have to put a unit on it because it's a word problem. And so, you know, what is it, 2 frames? Is it 2 what? And because x stands for the wooden edge around the end, around the outside, it's 2 inches. And that is our final answer for this one. So that puts everything together, all the stuff that you learned. You did foiling, you did adding like terms, you did the 0 product principle, everything all added together. Okay, and that is the last lesson, or the last example for lesson 9-4. So what you want to do now is pause and upload this to Canvas to get your points for the 9-4B notes. All right, I hope you guys have a great weekend and that you are successful with working on this ZPP homework. All right, happy Friday.